Welcome to The Explainer. Have you ever spent ages mastering a new skill only to feel it just fade away? Well, today we're uncovering the hidden mathematics behind why our brains learn so incredibly well, and yeah, why they're also so quick to forget.
You know the feeling, right? We've all been there. You pour hours into learning a new piece of software or maybe practicing an instrument. You finally feel that click of mastery, but then a few days later, you're just fumbling around again. It's so frustrating. But here's the thing. That feeling, that fade, it's not random. There's actually a science to it.
And that science? Well, it's surprisingly mathematical. See, researchers don't just, watch us get better and then get rusty. No, they map it all out. They give the entire process of learning a distinct and even predictable shape. The most fundamental tool they use for this is something called the learning curve. It's a really simple but powerful idea. It's just a graph that visually plots how your performance improves over time. So it takes that abstract feeling of, hey, I'm getting better at this, and turns it into a concrete, measurable mathematical shape.
Okay, but here's where it gets really interesting. There's a whole debate over the true shape of learning. Is it this slow, steady climb that kind of levels off over time? Or is it more like a rocket launch, a huge burst of progress right at the beginning that then quickly plateaus? Well, research suggests that the rocket launch model, that's probably closer to what you experience as an individual. The slow, steady climb tends to show up when you average out the performance of a whole bunch of people. And from here, believe me, the rabbit hole goes deep. Scientists have developed all these super advanced models for pretty much any situation you can think of. I mean, look at this list. Some of these are designed to factor in things like human fatigue. Others try to calculate how learning one skill might actually interfere with another one. It just goes to show you how incredibly nuanced the science of learning has become.
And get this, sometimes the path to getting good at something isn't a straight line up at all. In some cases, like how little kids learn to talk, their performance can actually dip before it gets better. It creates this really fascinating U-shaped curve. It's like this three-step process. You learn a simple rule, then you have to unlearn it when you find all the exceptions, and then you finally relearn a more complex, more accurate version of the rule. Wild, right? But everything we've talked about so far, that's really only half the story. To truly understand learning, we have to look at its other side, its counterpart, the art of forgetting. And yeah, it is just as crucial and, believe it or not, just as mathematical. So this right here is the classic forgetting curve. It was first mapped out by a guy named Herman Ebbinghaus way back, over a century ago. And honestly, it's pretty brutal. Just look at how fast our memory retention drops off. Within a single day, just 24 hours, you can lose more than half of what you just learned. That is, if you don't actively do something to remember it.
Okay, so we know that we forget stuff, and we forget it fast. But how does it actually happen? What is going on inside our brains when a memory just fades away? Well, scientists have a few really powerful theories about this.
So one of the main ideas is something called chipping. The theory here is that forgetting isn't some big single event. Instead, it's caused by all this constant background noise in our brain's neural networks, just tiny random things happening that slowly, piece by piece, erode a memory. It's kind of like how wind and rain will chip away at a stone statue over many years.
Another really powerful mechanism is called retroactive interference. And this is the idea that learning something new can actively mess with something you've learned in the past. It's like your brain trying to make room for new information can accidentally disrupt or even just totally overwrite older memories that it doesn't think are as important anymore.
And this whole concept is so important, it's actually become a massive challenge in the world of artificial intelligence. They call it catastrophic forgetting. And it's exactly what it sounds like. You can train an AI to be an absolute expert at one task, but the second you try to teach it something new, poof, it can abruptly and completely forget everything it just mastered. It's a huge problem. Now, I know this might all sound like abstract theory, but it's not. This mathematical understanding of learning and forgetting has some incredibly practical and honestly pretty surprising applications in the real world, specifically on the factory floor. That's right, we're literally connecting the dots from the neurons firing in our brain directly to how efficiently a factory runs. These exact same cognitive models are being used to optimize everything from production schedules to how a company manages its inventory. It's kind of amazing. And one of the biggest insights they've gained from this is actually a little counterintuitive. By modeling how workers learn a new task and then how they start to forget parts of it during breaks in production, companies figured out something crucial. It can actually be more efficient to have fewer stops and starts, fewer machine setups, even if that means you have to hold on to more inventory.
It all boils down to this really core economic trade-off, right? As workers do a task over and over, they get faster. That's the learning curve. And the cost to make each item goes down. But every time you stop production for a break, the forgetting curve kicks in. People lose a bit of that skill, and the costs start to creep back up again when they restart.
And the most advanced models, they get even more sophisticated. They don't just track learning and forgetting, they also factor in the real-world effects of worker fatigue and the positive impact of recovery breaks. So it becomes this really delicate balancing act. And that brings us to the most important piece of the puzzle in all of this, the human factor. And this is where the conversation gets a lot bigger. We're not just talking about making widgets faster anymore. We're talking about knowledge itself as a strategic asset. Something you can invest in, sure, but also something that can decay and disappear if you're not careful.
I mean, think about it. This totally reframes the concept of training. The time and money you spend on it, it's not just another expense on a spreadsheet. It's an active investment in a really valuable but also perishable asset for any team or organization.
And this principle is totally universal. It doesn't matter if you're talking about a factory, a software development team, an engineering firm, or a research lab. It makes strategic sense to invest heavily in that learning and training right at the beginning of a project. You build up that knowledge base when the returns are highest, before that inevitable forgetting curve really starts to kick in. Which really leaves us with one last huge question to think about. We can now model the act of forgetting with incredible mathematical precision. So, can we use that knowledge to design systems that don't just plan for forgetting, but that actively prevent it from happening in the first place? The answer to that question could literally change the future of how we all work and learn.